We are moving from agents that answer questions to agents that get work done. They plan steps, use tools, remember context, validate results, and route approvals, so a goal can become a completed workflow. Quick checkpoint. You now know that agents are goal-oriented systems, not just chatbots. You've also seen how tool calling lets them act through APIs, scripts, databases, or blockchain functions. Now we'll connect those actions with planning and memory, so an agent can choose next steps, preserve context, and run longer workflows. A single tool call is like asking an assistant one precise question. What is this wallet's ETH balance? The agent calls the right tool, returns the answer, and stops. Real applications are closer to project management. The agent has to break a goal into steps, run them in order, carry findings forward, and decide when the work is complete. Planning creates the path. Memory keeps each result useful for the next decision. Task decomposition turns a messy goal into a sequence the agent can execute. Instead of treating research this token as one huge request, the agent breaks it into checks like metadata, liquidity, holders, and risk summary. Each step can choose its own tool, produce evidence, and reveal errors early. From there, the agent cycles through plan, act, observe, and update, so progress stays inspectable and recoverable. Planning is not one size fits all. For predictable work, like generating a portfolio report, static planning is efficient. Define the steps, then run them. When results may change the next move, dynamic planning is safer, especially for contract interactions or uncertain market data. Hierarchical planning helps with larger goals by breaking them into phases and subtasks. Constraint-aware planning adds guardrails like budgets, permissions, time limits, and risk thresholds, so the agent stays useful without becoming reckless. Under the hood, an agent repeats a small decision cycle. It starts with a goal, makes a plan, takes an action through a tool, and observes what came back. That result is not just output, it becomes new context. The agent updates memory with facts, choices, and intermediate work, then decides whether to continue, change strategy, ask a human, or stop. This is how agents handle uncertainty without knowing the full solution up front. Memory is not one bucket. Conversation memory keeps the immediate thread coherent, but it should fade quickly. Vector memory supports recall by meaning, so the agent can retrieve relevant documents or past cases. User preferences persist across sessions, shaping defaults and personalization. Application state is different again. It records durable workflow facts, approvals, and transactions. Good system design separates these memories because each has different accuracy, privacy, retention, and storage requirements. Conversation memory is the agent's short-term workspace. It keeps recent instructions, clarifications, decisions, and tool results available, so the user does not have to repeat themselves. But it is not unlimited, and it is not permanent truth. As a session grows, older details should be summarized, irrelevant details dropped, and sensitive data avoided unless truly needed. The goal is useful continuity, with working context that stays focused, safe, and current. Vector memory gives an agent searchable long-term recall. Documents, case histories, and knowledge bases are converted into embeddings, so the agent can search by meaning, not just keywords. When a user asks for something, the agent embeds the query, retrieves the most relevant memories, and filters them by permission, date, source, and freshness. Only that evidence is added to the prompt. When decisions matter, the final answer should include traceable sources. Persistent memory is where a blockchain agent keeps durable context across sessions. It can remember preferred chains and tokens, risk limits, notification choices, and approval rules. It can also track past payments, swaps, contract calls, execution results, and where a workflow left off. That makes retries safer and behavior easier to explain later. But persistence should be selective. Store only what the agent truly needs, protect it carefully, and keep logs clear enough for audits. A useful way to design memory is to define boundaries. Short-term memory should hold only the context needed for the current task. Persistent storage is for durable app state, preferences, and user-approved data. Sensitive material, like private keys, seed phrases, or unnecessary personal data should not be stored at all. Anything you do store needs controls, retention limits, access rules, auditability, and a reliable way to delete it. Workflow graphs turn an agent from an open-ended loop into a controlled process. Each node has a job: research, validate, approve, execute, monitor, or report. Edges define what can happen next, including pass, fail, retry, or needs review. The main benefit is governance. You can insert human approval, test each step independently, and observe where work breaks down. For complex agents, graphs make behavior more predictable without removing flexibility. In practice, this becomes a safety pipeline. Research nodes collect facts from RPCs, indexers, APIs, or documents. Validation nodes test those facts against rules, balances, permissions, slippage, limits, and risk. If the next step can affect funds or state, approval nodes create a deliberate checkpoint from a user or policy. Only after that should execution nodes submit transactions, call contracts, or trigger systems. This separation keeps agents useful without making them reckless. Here, the agent turns a broad request into a controlled workflow. It gathers wallet activity, then enriches each transaction with meaning, such as swaps, NFT transfers, bridge usage, or high gas events. Next, it validates the findings by checking for anomalies and avoiding unsafe actions. Memory personalizes the output: preferred chains, report format, and risk sensitivity. The result is not just data retrieval. It is a reliable, user-specific report produced through clear steps. To build useful agents, focus on 3 layers: plan the work, remember the right context, and coordinate execution through structured workflows. Together, these turn simple tool use into reliable multi-step behavior. Next, we'll add the controls that make that capability safe: permissions, guardrails, approvals, and risk monitoring.